Hello guys and welcome to Simulogical. Today I'll be performing a simulation on a spring. This simulation will be performed in static structural and hence a static structural module is taken. I'm constructing the geometry in Design Modeler, but you can construct it in SpaceClaim or the newly Discover. Let us set the units to millimeters. I'm going to sketch on the XY plane. On this XY plane, I'm going to draw a line that is vertical. This vertical line represents the height of the spring. Now, if we want the height of the spring to be say 100 millimeters, then this line has to be 100 millimeters. Or you can increase the height to match whatever spring dimensions that you have. I'm going to create another sketch on the XY plane, and on this sketch I'm going to sketch the cross section of the wire of the spring. The cross section wire is usually circle, but you can also take it as square if you are using a square cross section spring, but square is not usually used and circle is much widely used in the industry. Now the distance of this center of the circle from the center line of the first sketch, this represents the diameter of the spring that we will be using. Now I will use the sweep command to create the spring shape. Now a spring is actually a helix that is wrapped around the entire vertical line on the XY axis. One thing that must be kept in mind is that both the straight line or the which represents the height of the spring and the cross section must be on separate sketches. I am going to use the number of turns in this. We can use twist or even module or even the pitch of it. The 20 I will use just to show that this is a spring shape, but in this we can see that my spring is completely turned onto itself and each coil loop is touching each other. So I'm going to reduce it to 10. That is much better. Now I'll open up the setup. Within the setup, let us first mesh it on the default settings and to see what kind of mesh the default mesh that is generated. Now I can see that the default mesh that is generated is actually capturing the cross-sectional circular shape quite nicely as well as the helix. But I need a much finer mesh, so I'm going to change the settings or the default size to be exact. Okay, the cross-section circle has been deformed or defeatured out. So I'm going to change it again and reduce the element size. And yes, at this element size, we can see that the circle cross section is being captured, but a more finer mesh is required. As I've said in my earlier videos, finer the mesh, the more better the physics is getting captured. Now, whether that be a structural analysis or a fluid flow analysis in Fluent. And we can see that the number of elements is quite high as we are using a finer mesh. Now let us move on to the structural setup. In order to provide the deflection, I'm going to give a fixed support to the face. One of the face that I'm going to choose is the front face of the cross section on which of the coil. And just for the example purpose, I'm going to use the displacement. I'm going to provide a displacement that is in line with the axis of the spring, which is in this case in positive y direction. So I'm going to provide this as 10 millimeters. I'm going to keep the x and y free in this case, and that is because as the spring deforms, it also has the tendency to coil onto itself as well as in the z and as well as x axis. So the radius of the coil may also change. So I need deformation, the stress and the strain. And now that all the conditions have been set up, I'm going to solve it. Now that the solution is done, we can see that the spring has deformed. Using the wire mesh, I can see that the original shape it has deformed by 10 millimeters, which was also the radius of the coil or the wire which the spring is formed of, and hence we can see that it has clearly moved upwards in the plus y direction. With this, I can also see that uh, the undeformed shape, which is in the light shaded region. This is the stress and strain. The locations of high stress and high strain usually follow hand in hand, uh, other than with the difference being in their values. With this, we can see the deformation over time. As we have given the deformation, I have given the deformation of 10 millimeters in a ramped position, in a ramped way. Okay, in this position, I can show you much better how the spring deforms over time or as the load applies. Similar case is for the strain as well as stress. Thank you for watching guys, and for more such videos, please subscribe and watch my other videos. Thank you.